faulty networks. I work for a company called the Flat Planet Phone Company, established actually in 2005, but really started working in 2006. We do primarily hosted PBX solutions, as many people here do. We also do SIP trunking. We do a lot of wholesale origination and termination. We have a few companies now. We started small here in New York under the Flat Planet Phone Company brand. I was employee number 2. Got a little bigger, bought out one of our suppliers, Omega Telecom in Cyprus, bought out the equivalent of a CLEC in Israel. Newtel Systems is now a brand here in America, and Phone.do was a new startup that was started about a year ago. So only 2 topics I really want to cover today. The first one is issue with SIP packets. I'm talking about SIP packets. I'm talking about the signaling, about the packets getting from point A to point B, primarily over the internet. You would think it would be easy, but obviously there's a lot of problems, and then issues that we have with RTP packets getting there. Okay, so I hate port 5060. Well, not really. I hate what has happened to port 5060 and all the devices out there and what they've done with it. So what do I really hate? Well, I hate ISPs that don't like the competition. ISPs that'll go ahead and mess around with your packets and try to make you problems and play as if they're doing nothing wrong, and then when you contact them, everything is fine. Script kiddies, aka hacker wannabes, we won't even call them really hackers, but what they're doing is they're looking for vulnerable systems. They're going to target your systems. They're going to send invites and try to see if you have a vulnerable system. This was a lot more, well, it still happens today. It was a lot more prevalent going back 10 years ago when there was little information out there about security, and everybody went ahead and took all their extensions and dumped it into one context. All the SIP peers are going into one context, and hackers would just go ahead and send an invite, and you had a lot of clueless people out there in the beginning that didn't know much about security. It was a cool project asterisk. I myself, well, didn't actually get hacked, but people did get in to an extent. So you have people that are just trying to go ahead and find vulnerable systems. And again, they're primarily targeting port 5060, although now people are starting to lock things down. So they're going after other ports. I personally have all my boxes in other ports, and I've seen invites coming to them as well. Horrible NAT implementations. This drives me crazy and keeps me in business at the same time. So it's a love-hate relationship. And devices with poor SPI setups. This is pretty much falls under NAT. We have customers that whenever there's a problem with this, whenever there's a problem, one of the first things that we do is we check, do you have SPI enabled? Good, disable it. And most of the time, that goes ahead and fixes the issue. Oops. So the RFC says that port 5060 should be used for SIP. You could be using UDP or TCP, with UDP being mandatory, TCP being optional, and TLS should be used on port 5061. Okay, so I think I went over. Okay, ISPs. So the first issue we have with ISPs is the ISPs that don't like competition. This is fairly simple. They don't want you to be making phone calls. In most cases, they're also the local phone company. And if you're going to be using SIP and not using them, they can't rip you off and make all their money. So they're simply going to go ahead. They're going to block port 5060. You're going to try to make a phone call. It's just not going to work. As much as this is a pain, this is actually the easiest one to figure out, because all you have to do is go ahead, change 5060, put in something else like 5090, and if your phone call works, you know it's either your NAT device or you know it's your ISP. But you know somebody's playing games, and these are the easiest ones to actually figure out. And then once you switch to port, everything works perfectly fine, but you know somebody's trying to screw around with your traffic, but at least you figure out how to get around it. Other ISPs are going to be a little bit more complex. They're going to make your life a little bit more miserable. If they just block port 5060, then you know what the problem is. You can get around it. So they'll go ahead and they'll block every other packet. They'll block every 10th packet. They'll go ahead and drop only your ACKs. So when a call is initiated, you get the 200 OK, the audio starts being passed. The ACK is sent, but you don't get it. And you keep waiting for it, and then asterisk by default, after 30 seconds, if it doesn't get that ACK, it's going to hang up the call. So as far as your customers are concerned, they're making the phone call, there's audio, and 30 seconds later the call dies. So whose fault is it? Obviously, it's yours. Then the next thing that we have is we have the buggy ITSP, ISP. As an ITSP, we're multi-home. We have multiple upstream BGP providers that we use to connect to the internet. So at one point, we had a bunch of customers who were having this problem where the phone calls were lasting for 30 seconds, and then all of a sudden the calls were dying. We're running VoIP modern on our end. We're looking at the PCAPs. Everything looks fine. The call should be working perfectly fine. But then I notice that we're sending that, I forgot which way it was, but again, the acts were being dropped and the calls were lasting for 30 seconds. So we did a lot of traces from the customers that were affected, and the common denominator that we found that all the packets that were being dropped, it was a select packet, I believe it was the ACK packets that were being dropped, it was all going in through a particular gateway at a particular ISP. When we contacted them and we spoke to them about it, it turns out that they had an ACL in their device that was not supposed to affect us. It was only supposed to affect another customer. It was only supposed to work for one specific customer, and they had a bug in the system, and as soon as they removed that ACL, all the traffic started working perfectly fine. Then we had another issue where we're located in New Jersey, and we're using a popular ISP down there, and we had a problem where we had customers that had an issue where randomly phones in the office wouldn't work. So one time it would be extension 100 that had a problem. They would talk. What happened was that they would get an incoming call. The call would be working perfectly fine. They would hear the person calling them, but when they spoke, the person that they called could not hear them whatsoever. Doing a lot of tracing, so okay, maybe it's a faulty switch, maybe it's something at the customer's location. We couldn't figure it out, and it was jumping around. So now it was extension 100, then it was extension 101, then it was extension 102. Then other customers in the same area also started complaining as well, and again, the exact same symptom. So we're ruling out the customer hardware because it's different customers, different pieces of equipment. The only common denominator was that it was one specific ISP that was having the problem. And of course, this big tier 1 ISP will never admit fault and never say they have a problem and everything's working perfectly fine because, as Jared said in the beginning, everybody has perfect networks and everything works perfectly fine and there's never any problems. Then when I was in the office and we're using the exact same ISP and I SSH'd into the box to see what was going on, one of the many times I connected, I hit the enter key, I wait for a response, and instead of having an immediate response, because we're maybe 10 milliseconds from where the servers are, and I notice nothing happens, I wait about 2-3 seconds, and all of a sudden on this SSH session I see the line drop and I see I did it. So I press the enter button again, and the exact same thing, there's a lag. Disconnect, I reconnect again, works perfectly fine. Did about 20-30 quick SSH sessions. Everything worked perfectly fine. Then all of a sudden, again, the same thing happened. So it turns out they must have had some kind of layer 2 device or something in the middle where the traffic was going, where every so often one of the sessions would, not sure, get stuck or something. They weren't targeting VoIP, because I mentioned it was happening on SSH as well. It was happening with all sessions. We put in a complaint. Again, obviously, there's nothing wrong with our network. Everything is perfectly fine. And magically, 2 weeks later, the problem disappeared. Then the last thing you have is the ISPs that are not really sure what's going on, and they'll never admit fault. When we first started in early 2005, we had a bunch of customers in Israel that were having a problem where they were sending us calls, and randomly they would send us calls and we weren't getting them. And we're tracing based on the customer's IP address. They're telling us they're sending us a call. We're looking on our end. We're not receiving the call, on and on and on and on. Eventually, for some reason, I don't remember why, I decided to go ahead and trace the calls based on their username that they were connecting into the system and not based on their IP address. And now we're on the public internet, all public IPs, we're not using any NAT whatsoever. And I noticed the invite coming from the customer's phone, except the source IP is a local IP address and not a public IP. Again, ISP is never going to admit fault, but from what I was told, back in 2005, they just assumed that nobody else on the network was using SIP and it was just them, and they were fixing the packets to make it work better on their network. So here's a small example of something that will make your life miserable. There's a good website, Explain Shell. Oh, my laser. ExplainShell.com, where you could go ahead and put in a line from bash and it'll explain you what's going on. It does a pretty good job. So you have an IP tables, A4, we're using the forward chain. That's any packet with a destination of port 5060, where you can use the statistic module, mode random, probability 0, 1, which is 1%, JDrop. So on average, 1 out of every 100 packets, we're going to go ahead and we're just going to drop it. So you have phone calls, it's working, there's no jitter, MTR is perfectly fine, everything is working perfectly wonderful, and the only thing that you see is every so often a single packet drops. Now using TCP here would help. Of course, they could go ahead and make it a bit more complex. They could go ahead and increase that probability. They could go ahead and, instead of having it being done in IP tables, they could have IP tables pass along the packet to snort, which is a lot more complex. And they could go ahead and select specific packets that they want to go ahead and they want to drop. Sorry. So they could say AX. They could say AX with, specific usernames. They could get as complex as they want, and they can mess around, and this will make your life miserable. Script kiddies, an unskilled individual who uses scripts or programs developed by others to attack computer systems. That's how the Urban Dictionary describes it, and this is what I think of script kiddies. There we go. Thinks they're hackers, but they're not. So when it comes to SIP, I'll step back a second. We had customers, and I'm sure a lot of guys have had, and I mentioned it earlier, where you have packets randomly coming into your network. We had the issue. Who else here has had issues where customers complained where they're getting ghost calls on their phones, where the phones are randomly ringing? So these are our friends, the script kiddies. And what they're doing is they're going ahead, they're sending SIP invites, they're trying to find vulnerable systems, they're trying to find, I mentioned earlier, systems where somebody perhaps didn't code the system correctly, and they're going ahead and they're trying to make phone calls. So the first time we stumbled across this, obviously we don't see anything on our network, all the monitoring tools are fine, no packets are coming through. And obviously we realized that the phones were sitting either on a public IP or they were sitting behind a full cone NAT, and the phones were accepting invites from everywhere. So we went ahead and we looked, and eventually we found this problem. Now, as per the RFC, there's nothing wrong with sending an invite to a phone, but most phones should not be accepting invites unless it's coming from the proxy. For some reason, a lot of phones out there are shipped by default, that they'll get an invite from any source, it doesn't matter where it's coming from. They'll accept that invite, and they'll ring, and they'll answer the phone. But that shouldn't happen, because realistically, if you have a phone, it should by default be set to only go ahead and communicate with the proxy that is registered or with the system or systems that it's working with, and it shouldn't be getting packets from anywhere else, and if it does, it should get dropped. Why companies do this, I have no idea. So interestingly enough, when it comes to fraud, I think we have in our company, a pretty good handle of when it happens. We have algorithms, we have scripts, we have blacklists, and usually when there's fraud, we detect it pretty instantly, and usually the policy is that if we have a number that's called, we instantly shut down the account. We first shut down the account, and then we ask questions later. We have customers that have lost $35,000 in 10 hours, and Nir, I know, does a lot with fraud, and he could tell you about customers that have perhaps lost millions of dollars fairly easily just from having an unsecured system. So one of the things that we noticed is we had customers that had fraud, and it was very hard to detect because the packets, the invites, all the calls were coming from the customer's phone, but the customer was denying ever making those phone calls, and these phone calls were happening in the middle of the night. So I wanted to believe the customer they were making the calls, because why would they head and call fraudulent numbers in the middle of the night, but the packets were coming from their phone? Normally when we see fraud, it's either a asterisk PBX that was compromised, username 100, password 100, and then the fraudster will go ahead and register that phone from their home and make the phone calls, or either they'll host a PBX where username 100, password 100, they'll make the phone calls through the customer's PBX, and that way we have no idea that it's fraud unless we have that number in our no-no list. Or the other way is they'll get the credentials out of the phone. There's a lot of phones out there that are still sitting on the internet with username, password, admin. You can go on Showdown, there are a dime a dozen, you can find these phones. You take your credentials, they put it into a phone and it works. We also found, getting off topic, but we also found with Polycom phones, most people, the passwords that they put into their phones is just a numeric password to make it easier when they want to configure and manage the phone. And what they were doing is they were brute forcing the phone. They would then go ahead and get in, change the password. Polycom, I don't know if they still do, but they had an option to downgrade the firmware directly from the web interface to a version which allowed you to pull the configuration, including the plain text password, directly out of the phone. But anyways, getting back to SIP invites here. So we kept them digging, and I said there has to be a way where they're manipulating the phone without getting web access to the phone, because we've already established there was no way of them getting into the web interface. So how were they making these fraudulent calls? After banging my head for 2 days, I figured out what they were doing is that, well, most probably what they were doing is that they were going ahead, they were sending a SIP invite to the phone with the auto answer header on the phone. So now when they send an invite to the phone, not only is it ringing, but instead of ringing, the phone's going to go ahead now and answer the call. Okay, so besides being creepy, what's the problem? Now they can hear what's going on in your office. Well, now what they do is they go ahead and they send they send a 302 to the phone, and they tell the phone to go ahead and redirect the call to a number somewhere else, to a number where they're going to go ahead and make money. So now here we have an invite, a crafty invite. All you needed to do is add the auto answer header, do a transfer, they're making money, no passwords were compromised, and you let them straight in by just having a phone that was open, that was just accepting packets from 5060. It got so bad to the point that what we actually started doing is we wrote a script where we looked in our open SIP system, and we found all the phones that were using this particular vendor that were listening on port from 5060 to 5065. If we were able to go ahead and successfully send it an invite and they responded with an auto answer, and then we were able to do a transfer, we sent them all emails, manually followed up with each and every single one of them to have them lock down the phone. So by default, it will only go ahead and accept invites from our system that they're connected to. All right, NAT, the bane of my existence. I hate NAT, I hate NAT, I hate NAT. I can't say that enough. IPv6 has been around long enough that everybody should be on it, but NAT is still around, and it's the reason for my talk, so let's get one good thing out of it. So IPv6 has been out. You could go on YouTube, there's a video, I believe it's called Fanboy IPv6 versus NAT, which is funny, makes fun of it. And there's also a website called IPv6excuses.com, which will randomly spit out an excuse why you can't deploy IPv6. We're in the process of deploying it, and the problem that I'm actually having is that the ISPs, where I'm located in New Jersey, have a poor reputation of working with NAT. I don't want to use tunnels, I want to use real case. They don't work with IPv6, real case to work with it. So that's the reason why we've been slow to put it out. One thing I want to say is NAT is not security. People wrongfully assume NAT is security. NAT is simply just works as a stateful device. So when a packet goes out from inside the network, NAT will go ahead and it will allow packets to come back in, but it's not providing security. It's not doing any security whatsoever. So common issues that we've found with NAT. Like I mentioned earlier, the first thing when we have customers, besides for having customers change the ports, another thing that we do is we check if we have SPI enabled. If SPI is enabled, the first thing that we're going to do is we're going to go ahead and disable it. Many times when a customer has a problem, so we disable, I mentioned this earlier, we disable SPI, instantly the calls stop working. It's supposed to make things better, it's supposed to keep track of all the packets, it's supposed to make things work, but rarely, if ever, does it do it. When I was working on this speech, I went on Facebook and I went on some email lists and I asked people to give me ideas because I want to cover as broad of a spectrum as possible when it comes to networking. And pretty much every single response that I got from everybody that their biggest problem was SPI, and that it just interferes every single time with all the packets. Full co-NAT. So there's different kinds of NATs. The way NAT essentially works is that when you have a device that's on a NAT device, say its IP address is 192.168.0.10, it's going out to server 200.200.200, port 5060. The source port on the packet is 5060. It goes through the NAT device. The NAT device goes in and says, okay, it's 192.168.0.10. I'm going to strip that out. I'm going to put in the public IP address, and I'm going to send it out to the IP. Now, when the packet comes back and then goes ahead and knows, well, the packet's coming from 200.200.200, port 5060. It's going back to our public IP. I know this phone has the session open. I'm going to pass the packet along. So there's different ways of NAT, whether full co-NAT, which means that once this port is being used, once in the NAT table, it has 5060, even from just this phone. If any other device out there goes ahead and sends a packet to 5060, it'll send it along to the phone. And as I mentioned earlier, the issue with the phones, when people go ahead and send it invites and with the auto answer and then send the 302, people are wrongfully assuming that NAT's covering them, that NAT's giving them security. They don't even know what kind of NAT they have on their device. And the second that phone is connected and the second that phone has a session open with an external server, automatically you're inviting the dregs of society and the script kiddies to come back in and send you packets and make you miserable. So if you're going to use NAT, unless you have a reason to use full cone, like you're a gamer or using Skype, and you want the media to go direct, you should have that locked down. Dual WAN devices and load balancing. So you have a lot of customers that'll go ahead and have more than one internet connection. They want reliability. They want that if one want reliability, they want HA, that if one goes down, they have the other one. They want to split their bandwidth. So if they're in an area where they don't have enough bandwidth, they'll go ahead and have two connections. So I'm going to cover this in a bit later on when it comes to the RTP section. But basically, what happens is the devices will go ahead, and for some reason, what it's supposed to do is it's supposed to, that if it has a session, send it out to the same internet connection because you're using that, and the device that you're talking to, the device that you're connecting to, is expecting the packets to come from this particular IP and from this particular port. Well, what happens is we found that every so often you'll have a device that will randomly go ahead and switch that port. Now, Now in Asterisk there's a setting. It started, I believe, in Asterisk 10 when it was defaulted to yes, strict RTP equals yes, where if you switch to port in middle, Asterisk is going to drop the packet. I'll speak about that in a bit, why it does that, but it'll drop that packet. So every so often we have customers where they're on a phone call and either the port will switch or the IP address completely will switch, where all of a sudden the IP will switch. And I mentioned Asterisk has no problem if you switch the media port or IP, just go ahead and tell it that you're switching the IP. But the router that's doing the load balancing doesn't know much about SIP because we just disabled SPI. So it's just going to switch it, and Asterisk is going to get traffic from randomly a different IP address, and it's going to go ahead and it's going to drop it. Changes that won't take effect until there is a new session. This is not limited to NAT. So as I mentioned earlier, I mentioned earlier you have sessions with NAT where when a packet goes out, it's keeping track. What happens is the way networking devices work, firewalls work, if we go ahead and we have a packet, we have a rule and we say any packet that's going to port 5060, allow. So along comes the first packet. It's coming from, we use external IPs, it's coming from 100, 100, 100, source port 5060, going to destination IP 200, 200, 200, 5060. If the device goes ahead and looks in memory and it sees, is there a session open currently and what am I supposed to do with this? If there is no rule, it looks in the rules, it says, okay, any packet destined for port 5060 I'm allow. I have the session ID now in memory. Say I go ahead and have an internal timer for 1800 seconds, which is 30 minutes. I'm going to start that timer now, and I'm going to let that packet through. Along comes the next packet. I go ahead and look in memory. I said, okay, I already have a session up from 100, 100, 5060 to 200, 200, 200, 200, 5060. The session in memory says allow that packet. It goes through. If we now go ahead and change the settings, a lot of devices out there, I know for sure we had this problem with ScreenOS in the beginning. If you don't go ahead and kill that session, even though you went ahead and applied the new configuration, it will go ahead and it will allow the packet, because the first thing that it's going to do is go ahead and look in memory. So it's going to still allow that packet through. Now, where we had a problem with this is that we had a customer who was in a data center that was using NAT. So it's a high-quality data center if they're making you use NAT. So they were using a public IP of, say, again, 100, 100, 100. Data center went ahead and switched their IP for whatever reason. On our end, we're making them use a username and password and an IP address as well to lock them down. Data center made the change. They're trying to make phone calls, and our system is blocking them. They're getting a message that they don't have permission to make phone calls. So we go ahead and we look in the PCAPs, and we see on our end, traffic is still coming from the original IP that they had configured 100, 100, 100. Nope, data center looked. That IP is not even anywhere in their hardware. That was completely removed. It's 200, 200, 200. Back and forth, back and forth. It's your fault, it's our fault. Left the office, customer called me. As I mentioned earlier, we had this problem with ScreenOS where we were making changes and they weren't taking effect until we killed all the sessions. So I told the customer if he was able to turn off this box and use other boxes, turn it off. I didn't want to get into it, explain him, and go through everything, so I just told him to disable Asterisk for about 30 minutes. 45 minutes later, I had him turn it back on, and now magically his phone calls were working. What happened is that even though they made this change, because the session was up, and I believe their session was, I was assuming that the session was defaulted to 30 minutes, even though they changed that IP, because they were using qualify in Asterisk, every so often Asterisk is going ahead and setting those SIP options to keep the NAT hole open. So long as every single time a packet came along, the router went ahead, looked in memory, so based on the session, saw the IP that it should switch it to, the IP that it should be using for NAT, and it used it. It reset the counter to 1800 seconds. Well, say 15 seconds later, another packet comes and looks in memory and resets that counter again. So in order to get it to work, by just having the customer stop their Asterisk box, the session disappeared after 30 minutes in the data center's router, and then when the next packet came along, instead of going ahead and looking in memory because there was no session, it then went ahead and looked at its configuration, and the configuration then said to go ahead and use a different IP address, and then everything started working fine. Okay, so this looks like a good packet. This is, I'm going to talk about delayed packets. We could see over here we have a SIP invite. We see a 401. We see another invite again, and that's going to be with the nuance, 100 trying. We have media, 200 OK, and then I hang up the call. There's a buy, and there's a 200 OK, and everything looks good. So this looks good, and I'll get back to a minute why I'm saying it looks good, but there actually is a problem. So let's look at this trace. By the way, this is SNGrep. It's a really good tool. It's based on NGrep, which is network grep, and it's sort of like Wireshark straight out of the console. So we go look at what? NGrep is a network grep utility. If you want to go ahead and see the packets going over, you want to see everything that's directly going over. It's sort of like grep for network level. This is SNGrep, which works based on NGrep, and it's sort of like Wireshark in the console. So if you want to trace in real time and see what's going on, you can look at packets and calls as they're going through. There's a screen behind this where it lists all your calls as if it were in Wireshark. Then you could click on it and see it. You could click on the packet again and it'll give you more information. So this is a bit more wonky over here. If you could see, we have an invite, a 401 from asterisk, another 401 from asterisk. The phone sends another invite again, but there's no nuance over here. It gets 4 403s. Then it decides to wake up the client and send an ACK, sends another invite. Asterisk is a bit confused, looks a bit drunk, sends a 500. I'm not sure who's more drunk, asterisk or the phone. And then it sends another invite, another 500, sends an ACK. The phone tries to make a call again, and then there's a bunch of ACKs going on, and then I hang up the phone. So what's happening over here? So you'll have customers that sometimes will have jitter. Again, ISPs have no problem. Everything's always working fine. It's never their problem until you do a bunch of traces and absolutely prove to them that there's an issue on their network. So what happened is, in order to imitate the problem, I went ahead and I'll try to do a demo afterwards, where we went ahead and I put a delay in on this. I put a delay in on the client. This was using a soft phone, and I said randomly delay all packets between, I think it was 200 and 700 milliseconds. So the phone will go ahead. The phone will pass to the kernel, to the network layer to send the packet out, but the box waited X amount of seconds to send the invite. Well, as soon as asterisk gets that invite, it goes ahead and sends back a 401, but the phone never got it, so it sent it again. As far as the phone is concerned, it never got any response whatsoever, because again, this is where we're looking at it from the asterisk server side. Should have done a trace from the phone as well so you could see the difference. And then eventually, asterisk gets the original 401, so it sends another invite down. It sends an ACK to the original 401, sends an invite, but as far as the asterisk is concerned, the CSAT counter is way up. So now it's going ahead and it's already thinking it's up to invite number 3, or as far as the phone is concerned, it's just sent to invite number 2, and it gets really complicated, and then we just give up on the call. So over here, the reason why this phone call worked and the solution to do in such a situation is we're using over here TCP. So TCP is guaranteed the packets to go through. UDP, we just send the packet and we hope it goes. So because we're using TCP over here, before the packet is sent, we already established a TCP session. We've already made sure that we have a connectivity. So when the packet goes, if the packet doesn't get there, well, the packet does get there, just gets there delayed. It's gonna the local IP, the 2.5 is gonna go ahead and it's gonna wait for confirmation from 2.12 saying that it got the packet before it did anything. So if you look at the timer over here, there is a delay between the packets, but everything's done in an orderly fashion, even though it's 500 millisecond delay, but it's still going to work because we're going to wait for the packets. Another thing that we could do is if you have a customer that has problems, is to increase the T1 timer in SIP. You could tell the phone, or if you're having a problem with the phones, or asterisk, you could tell if you have a customer with high latency network to go ahead and wait at least 500 default's 500 milliseconds to wait at least 750 or 1 second before retrying. But then again, if you have a customer that has such lag on their network, even if the packets do get there, you're still going to have a problem with the voice. The quality is going to sound horrible. Okay, so enough complaining. So how do we go about fixing this? So as I mentioned earlier, we could use an alternate port such as port 5090, and this is going to help where we have the ISPs, the SPIs, and everybody else in between, and all the other devices that go ahead and butcher 5060. Where we have a problem where it's just a signal, we could go ahead and use TCP, because a combination of both. Use TCP. I'm going to speed it up. TCP, where you could go ahead and that'll help it. I'm going to try to speed along a bit more. Or you could quickly go ahead and you could use VPN such as OpenVPN, or if you're old school, use PPPTP. There are a lot of phones out there that have built into it VPN clients. such as the A-Link. I was told that Sangoma's phone has a VPN client built into it as well. All right, real quick, RTP and some of its issues. When using NAT, it's susceptible to hijacking. As I mentioned earlier, when we have NAT and you have in the SDP a local IP address, so if Asterisk is set up that we're using NAT, Asterisk doesn't really know where the packet is coming, where the RTP packet's going to come from, because in the invite you have a local IP address, but you're sitting on the public internet. So in the beginning of a call, there's a probationary period where Asterisk will go ahead and it'll say it's listening for RTP on, say, port 10,000, and then when it goes ahead and it gets packets to that port 10,000, it'll lock in, it knows the source address, and if any other traffic comes to it, it'll ignore it. So if you don't have strict RTP set to yes, and you just have it set to no, what can happen is if somebody knows you're using Asterisk, you're using by default an RTP.conf ports 10,000 to port 20,000, they'll go ahead, they'll generate a bunch of packets that look like it's UDP, they'll bombard your system, send you a bunch of packets. So when the call is established, Asterisk will go ahead and it'll see RTP coming from a specific IP address, and even before your phone has time to send the RTP, this hacker, this person that's trying to do the hijacking and denial of service will send you these packets, and then you're going to go ahead and think, okay, the traffic's coming from them, and you're going to send back the traffic to them. The way I found this issue is back when we were using an older version of Asterisk and we had strict RTP set to no, we had a customer that had a bad phone that was, even though the phone call was over, it was broken, it kept sending RTP packets, and they thought there was a ghost in their office, because randomly what would happen is people's phone calls, instead of coming to whoever was making the phone call, because they were sending packets on a specific port, any call afterwards that was established using this RTP port would go ahead and go to their office. So randomly throughout the day and night, they were hearing voices coming out of their office. As I mentioned earlier, some NAT devices like switching around ports midstream. Cover that when we did the load balancing. And it's very susceptible to jitter. So, wrong statement, but it's very susceptible to the problems of jitter. So if you have jitter, like I said, even if we figured out ways to take care of the SIP signaling, you're still going to have an issue with the audio when it's coming through. Using a VPN is not going to really help because it's going to severely delay the packets. I think we have 3 minutes for a demo. So one of the ways to get around working with, as I mentioned earlier, NAT issues is only real ways to go ahead and either use a VPN or to go ahead and use the Opus Codec, which is now in Asterisk 14. And I set up over here a demo where we're going to go ahead and make a phone call with G711. Then we're going to add some delay, and you could clearly hear the difference. So we're going to start off with a phone call, I believe using G711.
Visit the Asterisk website at www.asterisk.org.
And we just confirm this is using ULAW.
Asterisk is an open source, full-featured PBX and IVR platform that runs on the Linux
now we're going to go ahead
and a little bit of unicorn
introduce
blood. For more
jitter
information, visit
of anywhere from 0 to 500 milliseconds.
Asterisk is an open source,
And you can tell instantly, even with the jitter buffer enabled,
that runs on the Linux operating system
actually it's doing a good
and
job.
a little bit of unicorn blood. For more information, visit
it's starting to break up.
asterisk.org. Visit the Asterisk website.
And now it's going backwards, depending on how many milliseconds of delay it's going to give. So you can hear it.
Asterisk is an open source,
Now let's go ahead and disable ULAW. We're going to go ahead and only enable Opus, and we'll compare the quality. So it's not going to be perfect, because again, you're still introducing a high delay, but it's going to be a lot better than it was before. Load. Let me reintroduce the jitter. Now, let me just, here we go. And I guess my jitter was too much for it. Doesn't want to go out. Nope. Well, I guess I should have done this yesterday with dangerous demos. But anyways,
Visit
here
the
we go.
Asterisk website at www.asterisk.org.
And you could hear.
Asterisk is an open source, full-featured PBX and IVR platform.
We are
that
using
runs
Opus
on
now.
a Linux operating system and a little
And you can
bit
hear
of
it's pretty much
blood.
compensating very well.
For more
Opus has a
information,
setting
visit
where you can oversubscribe on the,
asterisk.org.
I forgot to mention earlier,
Asterisk is
where
an
you could go
open
ahead and oversubscribe on the bandwidth. So instead of sending the default amount of bandwidth that it's going to be using, it's going to go ahead and it's going to send double the amount of bandwidth. So if a packet drops or a packet gets delayed, it has a copy or has another packet of it, so it could sort of go ahead and make the quality go better. I know when I was flying in, like I said, we have a company phone that is very much based on the web, and they're using strictly, I believe, for their client on Android on the web, Opus. If I try to use a SIP client with UDP, you could barely hear anything. I went ahead and I used Opus, and the phone call worked perfectly fine. And I believe that's it. And I think I butchered PowerPoint. Yep, done. Any questions?
If you have a question, please raise your hand and we'll pass around a microphone so we can capture the question on the video.
You mentioned that some internet service providers are notoriously bad. I don't want you to necessarily name names, but can you name names of any companies that you've had great success with that are maybe national companies?
Well, it generally works until it doesn't, so I could probably give you more list than I can't, but of the companies that don't work and then the ones that do, here in the US, it's pretty much okay. We deal with a lot international, and that's where more we have the problems.
Okay.
I can't say who it is, but it's one of the major ISPs, and they do fiber in New Jersey. I'll just say that. They're the ones that had the problem with the delayed packets. You can figure out who it was. But in the US, for the most part, we don't have that problem.
Thanks.
It's mainly overseas.
All right, other questions? Now's your chance.
All right.
Going once. Going twice. All right, thanks everybody. Let's give him a great round of applause.
Thank you.